As your programs begin to make use of conditionals and Boolean expressions, both in if-then statements and while loops, oftentimes you'll realize you want to express a Boolean test that's a little more complex than just saying is x greater than some value or is something equal to something else. You kind of want to make compound tests. So if something's true and something else is true, then do something. Or if one thing's true or another thing's true, then do something. Or if not this certain test condition. Well, this is called Boolean algebra in mathematics, and in discrete math, you'll learn all about it. But let's go over the fundamental operators that we have available to us in the Python language. So the first is the AND operator. And I'm going to sort of use some notation here to say Boolean left-hand side, and this is our operator, Boolean right-hand side. Right? These Booleans are expressions. So we could put any expression here. For example, let's imagine we're trying to implement whether or not to allow someone into a bar on Franklin Street. One of our conditions could be, age is some parameter that was passed into this function greater than or equal to 21. And maybe there's a Boolean variable named has ID. And that has ID is either true or false. Well, this AND statement ensures that this overall Boolean statement will only be true if both of these conditions are true. So this is the impact of AND. If the right-hand side and the left-hand side are true, then the AND operation will evaluate to true. If one side or the other side is false, then it will be false. One of the common ways this is confused is false and false scenarios. Well, false and false also evaluates to false. And let's reason through why. Well, let's imagine that age was 20. So 20 greater than equal to 21. And has ID, let's say that was false. Well, this is false and false. And, if you're 20 and you don't have an ID, that doesn't get you into the building, even though both of these things are false. We're not saying equal to. So I think this is where people can commonly confuse equality. If this were instead of and equal to, false equal to false would evaluate to true because those two things are equal to one another. But the AND operator requires both the left-hand side and the right-hand side of the AND operation to both be true in order for it to evaluate to true. There's a common tool that we use called a little truth table, and we're just going to use a very simple version of this where we can say, okay, I'll put left-hand side, and it can be either true or false. And we'll make our little table here, and this works a lot like a multiplication table. And we have our right-hand side, true and false. And the way this works is the only path towards getting true is for both of the right-hand side and the left-hand side to be true. We'll get false in every other case here. And again, just like with a multiplication table, if you trace your fingers in one direction and from the other where they intersect, that's what you'll ultimately evaluate to. The key idea of the AND operator is that it takes a true value on both sides in order to get true, otherwise you get false. The opposite of the AND operator, or what tends to be thought of logically as the opposite, is OR. And so OR says either the left-hand side or the right-hand side. So if we look at the syntax, we would have, let me get back to a pen here. We would have a Boolean expression, and I might do this BE to be sure we're talking about expressions here. Left-hand side or Boolean expression on the right-hand side. Right? And this has, like an example of this is maybe if it is cold. So let's say if we have a temperature variable, if temperature is less than or equal to, say, 60, or precipitation greater than 0, then we want to bring a jacket, right? So the implications of the or operator are that either the left-hand side or the right-hand side or both sides can be true, and the or operator will evaluate to true. Let's think about the both of this. Well, because this is where or is commonly confused. People think or means it has to be one is true or the other, and that is not the case. If either side of the or operator is true, or both, the or operator will evaluate to true. Right? So let's say here, temp was 70. 70 less than or equal to 60. Well, this is false. But because we're using or, if precipitation was, say, 1.0, 1.0 or 11.0, that'd be a lot of precipitation. Probably don't want to go outside if there's 11 inches. Let's say 11 millimeters of precipitation. We haven't named our units here. And this is true. False or true evaluates to true. Right? And so we once again use one of those truth tables to explore this. And sorry, I was in the way here. Let me just move this. So because the right-hand side here was true, we got true. If this were flipped, if we had swapped these, the same would also be true. Either side or both sides need to be true in order for or to evaluate to true. The only way that you will have the or operator evaluate to false is if both sides are false. All right, so again, towards the end of left-hand side, right-hand side, and true, false, true, false. As we're thinking about our truth table, I just want to be sure I wrote those trues and falses in the same order. True and true, this is true. True and false is true, this is true. The only way to get false out of the or operator is when both the left-hand side and the right-hand side are false. If either side or both sides are true, or evaluates to true, right? And again, this is useful when you want to make it a little bit more flexible. You have an if statement or a while loop, and you're trying to do something that tests if one thing is true or something else is true, then continue on. For example, if the user pressed saved or the user has autosave enabled, then we'll save the file. Right? The not operator is actually the most self-explanatory of these. So these are all what we call binary operators because they have two sides to them. Same with the and operator. So these are binary operators. But the not operator is actually what we call a unary operator because it is not followed by some Boolean expression. Right? And this is pretty straightforward. So if you were to write something like not age greater than equal to 21.0, let's just do 21. And let's say age is 22. Well, this would evaluate, oops, this was 21. This would evaluate to true, but because we have not in front of it, not true is false. So the effect of not is it flips the Boolean expression. It's the opposite of whatever it is. So we're nodding something. And again, this can also be expressed in terms of a truth table in some ways, but because there's only one operator here, we would say, true, false, and then let's just say not above. Of course, not true is false and not false is true. All right, so we're flipping the Boolean there. As a means of review in what we just went over, here are each of those tables presented in a slightly different way, where we've got all of the expressions. And again, it's a little bit silly to see these as literals, like true and true. You would never write that, right? This is, you're always going to have, a Boolean expression here and a Boolean expression here for this to be meaningful. And it's only what they evaluate to when your program's running that you would then get true and true to ultimately result to true. But because we can write expressions on either side of these operators, we have more powerful logical capabilities at our disposal. I need to mention that in terms of precedence, when we think about what happens and gets evaluated first, well, first we have our arithmetic operators. Parentheses, exponents, multiplication, division, addition, subtraction. Then we have our relational operators. These are like greater than or equal to, less than, equal to, and so on. And then the next three operators are the logical ones we just went over. It turns out not has a greater order of precedence than and or. And has a slightly higher, I shouldn't say slightly higher, it has a higher order of precedence than or, and or is the lowest here. So if we were to go back, and I erased my example here, but when you reason through this, and you think about examples of this generally makes sense in how you would think about it. But when in doubt, this note is what's most important. Because parentheses have the highest precedence, when you don't remember the rules of these, and to be honest, like it takes some thinking about these. This isn't something I have committed to memory. I always have to reason through this, and it typically reasons the way you would expect. But when in doubt, and actually just to make your code easier to read, rely on your parentheses to enforce these by a de facto, right? So you can always use parentheses to set the order of precedence that you'd like to explicitly happen. But implicitly, if you don't use parentheses, this is their order of precedence. In Python, this little note here is a little bit funny to explain, but in Python has a notion of something called truthiness and truthy values versus false values or falsy values. And so like the number 0 is considered falsy, the number 1 is considered truthy. In fact, non-zero values are considered as truthy. But those rules are kind of beyond our concern and are a little bit muddy to remember and think about. When in doubt, just assume that you're always working with Boolean expressions. And so if you have a value 1 and you want to make it a Boolean expression, maybe you test is x equal to 1? Well, if x is 1, then that would be true, false otherwise. That's all we've got for the introduction to these logical Boolean operators. Using these, you can write more sophisticated logic in your conditional and while loop statements.